This is our full test suite for the clock class. It includes 2 unit tests, one for verifying the 24-hour time format and another for the 12-hour AM/PM format. The overall structure is the same for both. We use unit test mock patch to simulate a specific time value, and then we check whether the getTime method returns that value correctly and uses the expected format string. Since both tests are nearly identical in logic, for clarity and time, I'll walk us through just the 24-hour test step by step on the next slide. The 12-hour test mirrors that process with different formatting. For this test case, we're focusing on the getTime method of the clock class, specifically when it's set to 24-hour mode. The goal is to make sure that the time is being formatted correctly using the string %h:\m:\s, which is the standard 24-hour format. To test this, we're using Python's unit test framework along with unit test mock patch. This lets us mock the time string ftime function so that we don't have to rely on the actual system time, which helps us keep the test predictable. First, we use the @patch time.stringftime to replace the normal stringftime function with a mock version. Then we tell that mock to return 13, 29, 15 no matter what. This means we're not depending on the actual time on our machine, which makes the test repeatable and reliable. When we call self.clock24 getTime, it uses our fake time instead of the real one. So just to clarify, clock.24 is the instance we created in the setup method with format 24 equals true, so we're testing the right mode. Now that we've set up the mock and called getTime, we finish the test by making 2 key assertions. First, we use self.assert equal to check that the result matches the fake time we set. That confirms the clock is returning exactly what we expect. Second, we use mock stringftime.assert called with, and then the string formatting, to make sure the method used the correct 24-hour format string internally. These 2 checks together verify both the output value and the behavior of the method, so we know it's functioning correctly under our test conditions. This is our full test suite for the digital clock class. It includes one test case that checks whether the update display method correctly updates the time labels for both the 24-hour and 12-hour formats. Just like in the first test, we use mocking to simulate expected behavior. This time, not for the time string, but for the internal clock objects and the label widgets themselves. Since the 24-hour and 12-hour tests follow the same logic and only differ in the expected time strings, I'll walk us through just the 24-hour side of the test. The 12-hour part mirrors it with AM/PM formatting. So for this test, we're focusing on the update display method inside the digital clock class, well, specifically to the part that does the 24-hour label. The goal here is to make sure the label gets updated correctly based on the clock's time. So instead of checking the string formatting like before, we're checking that the GUI actually displays the right text. To test this, we're using Python's unit test framework, and we use mock to fake both the clock object and the label widget. That lets us check if .config was called with the exact string we expected without needing to show the real GUI. In this part of the test, we're setting up mocks for just the 24-hour side of the mock display. First, we mock clock_24, which is the internal clock object inside the GUI, so that we can control what getTime returns. We also mock the label itself, label_24, so we can later verify how it gets updated without needing to show the actual interface. Then, in the test, we tell our mock clock to return 13:00:00. This simulates a fixed time instead of depending on the system clock. Finally, we call update display, which is the method we're testing. This should trigger the label to update with the mock time. After calling update display, we finish the test by asserting that the label was updated with the correct time. This line checks that the label's config method was called with the string 13:00:00, which matches the mock return value we set earlier. It confirms that the right time was passed to the GUI, which is what the user would actually see. This kind of test is especially useful in GUI code where we care more about interactions and side effects than return values.